Hello, so today we're going to be going over practice test 4.2. I know it says test, but they are mislabeled, so this one is the practice test. The one that's labeled, and then your test on Friday is actually labeled practice test. I mislabeled them. I apologize. So we're going to be solving each triangle, and we're going to be rounding our answers to the nearest hundredth. We're going to be using law of sines, law of cosines, and Heron's formula today. So on number 1, we have angle side angle. So we have a law of sines problem. We're going to be solving the triangle, which means that we need to find all the missing pieces. So we need to find angle H, we need to find side K, and we need to find side P. So these are things we need to find to solve our triangle. So the first thing we're going to do, since we have two angles, we can find that third angle by subtracting from 180. So we're going to do 180 minus 93 minus 53, which is going to give us 35 degrees. Now I have all three of my angles. I have a pair. I have big H and little h, so I'm going to use my law of sines there. So I have sine of 35 over 14. And then I can solve for K or P, it doesn't matter. I'm going to go for K. So we're going to have sine of K, which is 53, over little k. So I need to cross multiply, which is going to give me K times sine of 35 is equal to 14 times sine of 53. Then I need to divide by sine of 35 on both sides. So K is equal to 14 times the sine of 53 divided by the sine of 35. You need to make sure that your calculator is in degrees. When you plug that into your calculator and round it, you should get that K is equal to 19.49. Now we're going to do the same setup, but now we're going to solve for P. So we're going to have sine of 35 over 14 is equal to the sine of P, which is 93 over little p. So I'm going to do the same thing where I cross multiply and divide. So P is going to be equal to 14 times the sine of 93 over the sine of 35. I'm going to plug that into my calculator, round to the hundredths. I should get 24.37. Oh, we couldn't see all my work, excuse me. So this is what we plugged into the calculator, and this was our result. We have solved our triangle because we found the missing 3 pieces, so we are all done. Now in our triangle, we can draw a little triangle for number 2 if we like. We have triangle FDE. We're given angle F is 108. We're given side F is 15.7. And then we're given side E, which is 14. So we're given side angle. So side angle is that ambiguous case. So we're going to take a look. Here our angle is obtuse. So we're looking at 2 options. We're either going to have one solution or no solutions. So F is my pair, and my pair is always A. So in this case, even though it's labeled F, we're looking at A and little a. So this is A, this is B. Since A is greater than B, 15.7 is greater than 14, we have one solution. So we're looking to solve this triangle. We need to find angle D, we need to find angle E, and we need to find side D. So we're using our law of sines with our pair. So this is sine of 108 over 15.7. And then the only other information we have is E. So we have to look for sine of E. We don't have an option on this one. We have to find E next because that's the missing point of our next pair. We're going to cross multiply. So I'd have 15.7 times the sine of E is equal to 14 times the sine of 108. Then I would divide by 15.7. So I have sine of E is equal to 14 times sine of 108 divided by 15.7. And then since we have sine of E, the way I get rid of that is sine inverse. So E is equal to sine inverse of everything we have right here, that 14 times sine 108 times 15, or divided by, 15.7. So I'm going to put that in my calculator. I'm going to round, and I'm going to get 58 degrees. Now that I have two angles, I have F and E, I can find angle D by subtracting from 180. So I'm going to have 180 minus 108 minus 58 gives me that D is equal to 14 degrees. Now we're solving for little d because that's the last piece of my puzzle. So I'm going to have sine of 108 over 15.7, and then I'm going to have sine of 14 over little d. So I'm going to cross multiply and divide. And so what I'm putting in my calculator, d is equal to 15.7 times the sine of 14 divided by the sine of 108. This is what I'm putting into my calculator. And that's going to get me 3.99. So our triangle is solved because I found all that missing information. Moving on to 3 and 4. So now I have side, side, side on 3 and 4. So that means I'm going to be using law of cosines. So what I'm looking for is to find all the three angles. So I'm going to need to find angle K, angle H, and angle P. Remember, I start with the largest side. So the largest side is 26. So the law of cosines form that I'm going to be using is P squared is equal to K squared plus H squared minus 2KH times cosine P. So I know P squared is equal to 26, or P is equal to 26, so 26 squared. K is equal to 18, so 18 squared. H is equal to 24, so 24 squared, minus 2 times 18 times 24, and then I don't know P, so it's cosine P, because that's what I'm looking for. So I'm going to do my squaring and multiplying. So my next step is to do my squaring and multiplying. So 26 squared is 676. 18 squared plus 24 squared is 900. And then 2 times 18 times 24 is 864, and that's times cosine P. I'm going to subtract 900 on both sides. So negative 224 equals negative 864 times cosine P. I'm going to divide by negative 864. So cosine P is equal to 224 divided by 864. And I need to take inverse because I need to get the big P out of cosine. So cosine inverse of 224 over 864. When I put that in my calculator, I should get that P is equal to 74.97. Now we need to solve for K or H. It doesn't matter. I went for K next. So we're going to have sine of 74.97 over 26, because that's big P over little p. And then I'm going to have sine of K, big K, over 18. So I need to cross multiply and divide. So I'm going to have sine K equals 18 times sine of 74.97 divided by 26, and now I need to use inverse. So K is equal to sine inverse of all that, 18 times sine 74.97 over 26. That gives me that K is equal to 41.96. And now I have two angles. I need to find that third angle, so I subtract from 180. 180 minus 41.96 minus 74.97 gives me 63.07. I found my missing pieces of information, so now I know all three angles and all three sides, so that triangle is solved. We're doing the same thing on number 4. We start with the largest side, so my largest side is 27. So the form that I'm plugging into is r squared equals p squared plus q squared minus 2pq times cosine r. Because our pair goes here, and then our other sides go here and here. So I'm substituting in. I'm going to have 27 squared equals 19 squared plus 12 squared minus 2 times 19 times 12 times the cosine of r. I'm going to do all the same steps we just did on number 3. So I'm going to multiply everything for my next step. So 729 equals 505 minus 456 times cosine r. Then I'm going to subtract 505, so 224 equals negative 456 cosine r. Then I'm going to divide, and I have to take inverse. So r is going to be equal to cosine inverse of 224 divided by negative 456. Oh, also, what we need to find are these three angles. So we need to find angle Q, angle R, and angle P. So r is equal to 119.42 degrees when I put this into my calculator. So now I have a pair. I have big R and little r, so I switch to law of sines. So sine of 119.42 divided by 27, and then I can look for Q or P, doesn't matter, I went for Q. So sine of Q is over 12. I need to cross multiply, I need to divide, and I need to use inverse. So Q is equal to sine inverse of 12 times the sine of 119.42 divided by 27. So when I put that into my calculator, I get 22.78 degrees. I have two angles. I subtract from 180 to find the third angle. So 180 minus 119.42 minus 22.78 gives me 37.8. So I have found all three angles, and I already had all three sides. So our first page is done. Excuse me, coffee break. Now we're going to flip over to number 5. So now we have side angle side, which is still law of cosines, but instead of having to use the largest side, I need to make sure I'm using this angle. So the law of cosines that I'm plugging into is z squared equals x squared plus y squared minus 2xy times cosine of z. Because this has to be our pair, what we're looking for, and then the other two sides are x, y, they go right here. To solve this triangle, I need to know all three sides and all three angles, so I'm looking for angle x, angle y, and side z. So when I'm substituting in, I'm going to have, because I need to take the square root, so what I'm rewriting, I'm going to have z equals the square root of all this. That's all under the square root. So I'm going to substitute. Z is equal to the square root of 27 squared plus 23 squared minus 2 times 27 times 23 times the cosine of 123. I plug all this into the calculator, and I get that Z is equal to 43.98. Now I have a pair. I have big Z and little z. So I switch to law of sines. So I have the sine of 123 over 43.98. I can either look for x or y next. I went for x. So sine of x over 27. I need to cross multiply, divide, and use inverse. So x is equal to sine inverse of 27 times the sine of 123 divided by 43.98. So I put this in my calculator, and I get that angle x is equal to 30.99 degrees. Now I have two angles. To find the third angle, I subtract from 180. So 180 minus 123 minus 30.99 gives me 26.01 degrees. I now know all three sides and all three angles, so my triangle is solved. Again, on number 6, I have side angle side, so it's a law of cosines case. I use the angle that I'm given. So the form that I'm plugging into is going to be that s squared equals r squared plus t squared minus 2 times rt times cosine s. And I know I'm going to have to do that square root portion. So I know s is equal to the square root of 14 squared plus 28 squared minus 2 times 14 times 28 times the cosine of 102 degrees. So that's all under the square root. I plug that into my calculator, and I get that S is equal to 33.81. I also need to find angle R and angle T. So I have a pair. I have big S and little s, so I have sine of 102 over 33.81. I look for R or T. I want for R, so sine of R over 14. I need to cross multiply, divide, and use inverse. So R is equal to sine inverse of 14 times the sine of 102 divided by 33.81. So in my calculator, that gets me that R is equal to 23.89 degrees. Now I need to take 180, subtract 102, subtract 23.89, and I get 54.11. So I know all three angles, I know all three sides. That's that triangle solved, excuse me. That way we can see all of it. So now we're not asked to solve the triangle anymore, we're asked to find the area. We're asked to find the area, and we have all three sides. So we're going to be using that Heron's formula. So remember, the semi-perimeter is 1/2 times A plus B plus C, because that's the perimeter divided by 2. And then Heron's formula is that the area is equal to the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C, and that's all the square root. So the first thing we need to do is find our semi-perimeter. So we're going to have 1/2 times 5 plus 12 plus 13. So our semi-perimeter here is 15. Now we are using our Heron's formula. So our area is going to be the square root of 15 times 15 minus 5 times 15 minus 12 times 15 minus 13. So instead of putting that all in our calculator, because we would have to do like a bunch of parentheses, we're going to do our subtraction first. So we're going to have the square root of 15 times 10 times 3 times 2, because I did all that subtraction. Now I plug this into the calculator, and I get a nice pretty number this time. Our area is 30. So 30 units squared. We don't know units, so just 30 is fine. Now we're going to do the same thing on number 8. Step 1, we have to find that semi-perimeter. So we have 1/2 times 9 plus 13 plus 14. That tells us that our semi-perimeter is 18. Now I plug into Heron's formula, so I'm going to have 18 times 18 minus 9 times 18 minus 13 times 18 minus 14. I'm going to do all that subtraction before I put this in the calculator. So this is going to be 18 times 9 times 5 times 4. When I put that all in the calculator and I round to the nearest hundredth, so 2 decimal places, we're going to get A equals 56.92. So our area for this triangle is 56.92 square units, but we don't know the units, so we can just leave it like this. On 9 and 10, we're doing the same thing, but now we don't have a diagram. We don't need a diagram. We have our three sides, so we're doing the same thing. We just don't have the picture. You can draw the picture if you want, but you do not have to. So our semi-perimeter is 1/2 times 13 plus 8 plus 6. When I plug that into the calculator, I get 13.5. So we got a decimal now. It's not as fun, but it's the same setup. So our area is equal to 13.5 times 13.5 minus 13 times 13.5 minus 8 times 13.5 minus 6. I'm going to do the subtraction before I put this in the calculator. So I have 13.5 times 0.5 times 5.5 and then times 7.5. When I plug that all into my calculator, I get that the area is 16.69 when I round that to the hundredths place, 16.69. Then our last problem, again, we're still finding the area, so we're still using Heron's formula. So my semi-perimeter is going to be 1/2 times 15 plus 15 plus 13, which makes our semi-perimeter 21.5. Again, we got a decimal. It's not as fun, or it's not as easy. More writing, more typing, but same formula. So 21.5 times 21.5 minus 15 times 21.5 minus 15 times 21.5 minus 13. Instead of putting in all these parentheses in our calculator, we're going to do the subtracting first. So we get the square root of 21.5 times 6.5 times 6.5 times 8.5. Plug that all into the calculator and we get our areas equal to 87.87. Alright, so we are all finished. So again, remember our practice test is in fact labeled test this time, and our test is labeled practice test. I apologize. I just made a mistake when I made the copies. So yeah. But I hope this helped, and then I hope this goes well on Friday. Yeah.